So this is the power supply, the battery charger that I built the other time to charge the batteries for the electronic cigarettes. It worked perfectly, just that the initial 5-volt voltage regulator, remember, that I was supposed to use, I broke the pins. So I had no option. I had the 7808, which is the 8 volts voltage regulator. So I used it, but it charged the batteries and very fast as well. But it was a disaster because the heating was, we didn't have any control over the current, and so much current was running through the voltage regulator. And I decided to put a heating over it, but still we don't have control over the current, and we can easily burn the voltage regulator. Remember, our transformer is 3 amps, so we have no control over the current. So I thought it okay for us to make the voltage, the power supply adjustable. Like we can move from 1 to 7 volts, so we can easily stop at 5 volts, control the voltage, and by so doing we can limit the current. The voltage is working with the current, so we can limit the current by reducing the voltage. Alright, so what we are going to do here, the way we can do it is by using a transistor. So I drew out the schematic for what we have here already. We have 8 volts on the output. Let's check. I have the transformer plugged into the main power, and I will check on the output for the voltage regulator. What do we have? 7.3. I don't know why that voltage dropped so much. It's not really 8, but it's 7. We'll work with that. 7 volts. So we're looking for a way to drop it down to 5 volts. In that way we can charge basically anything, ranging from a phone or any battery that we can charge with 5 volts. 7 volts is not really recommended because of too much current, like I said. Okay, so what we're going to do, we'll make the voltage adjustable, and that's why I'm going to use the transistor. That's the only way we can do it, but not the only way, but that's the way I choose to do it. So this is a C3012 transistor. It's a high power transistor. I got this one from an audio amplifier, and this one is like this. I took our time to draw the schematics again. Let me unplug this. So the transistor is like this. I'm drawing this out because we have to take note of the pins. So it has 3 pins like that, and here is the base, here the collector, and the emitter. Alright, so how is the transistor working? The transistor is working as an amplifier and as a switch at the same time. That's why we can have, like, if you want to draw that out in a circuit, it's going to be like this. Well, that's how they draw it, like this. And this is the emitter with the arrow pointing down. So here we have the collector, the emitter, and the base. So how is it working? We can have a small voltage here. So we always have voltage on the collector, that's it. For this voltage to move from the collector to the emitter where we can connect the load, we need to have the base to be compared with the emitter by 0.6 volts. So if you have 0.6 volts here, we can open this transistor. Maybe we have like 8 volts in our case, and we can move the 8 volts here with a small current. Well, the transistor is actually opened by current, but that's not the thing. So I'll try to draw the schematic from here. So we have 8 volts. We have 8 volts here, and we are going to take that straight to the collector of our transistor. Now our transistor here. Okay, you can't see that. We have the collector of the transistor here. This is the emitter, and here we have the base. So we have our 8 volts connected to the collector, and on the base, we can leave the base like that for now. And here we have ground. This is the emitter here. We don't have a load yet, so we'll leave this like this. Alright, so let's do it. So I was sold some very cheap soldering wire. It's really of bad quality, so I'm not very sure of my soldering skills today. The rosin that is in the middle is like expired. I don't understand. It gets dry very fast, and to burn is an issue. In fact, I'm using my 60-watt soldering iron and it's still not burning that as fast as I want. It's going to take so much time. No, I'm actually killing my book, and it's smoking so much. The solder wire. Let's do it here. That's hard. Solder wire is not working. Let me use some flux here. I'll dip the cable into flux. I guess that'll be fine now. This is crazy. How can anyone sell this? This is mad. Can't even do anything. It's not sticking to the wire. This is mad. Nothing at all. Can't believe. Okay, let me try to put the solder on the transistor. Maybe that will work. Okay, it's moving. Okay, and you stick to the transistor instead. uh, but the, I cannot continue this video because of bad soldering wire. You see, I cannot get to stick it on the wires. I cannot pre-apply it on the wires, and that makes the job very difficult or impossible. Because if you're soldering in air like I'm doing now, you will have to pre-apply solder both on the cable or on the wire and onto the component that you want to solder on those pins. If not, you will not be able to stick this wire onto this pin, and it's not possible. So in our case, this solder wire is what I got, and I don't know about this one. I don't know, but because it's the first time that I'm buying away from where I normally buy solder wire, and I didn't check, of course. So this one is very poor, but it's because maybe it can work for other applications like soldering big components in the fridges or something like that. But for electronics, it's not going to work because the rosin that is in the middle, the rosin is the isolating element that they put in there. Rosin is it's what makes the solder to flow. Is what exists in the lead element. So it's always in the core of the lead element, the rosin. So this one is getting dry very fast. Not because it's not rosin, but because it's maybe it's been exposed to some kind of weather condition, or maybe it's just of bad quality. But I can see the difference between this one and what I normally buy. This one has almost the same thickness. It should be like this is 0.8 millimeters, I think. And what I normally buy is 8 millimeters, is 0.8 millimeters too. But it's more shiny than this one. This one has a dull color. So if you find anything like this one and you want to buy, you better avoid it, because you'll not be able to use it to build anything. It's really it's dry, kind of. It's somehow somewhat dry inside, and I think that the rosin inside is very small too. That's why. So I'm going to end the video here, and probably I'm going to continue with making our 8 volts power supply to be adjustable. Let me know what you think about this video in the comments, and like and subscribe to the channel for more videos, and we'll do something else in the next one.